Alright, so today we're going to be learning how to divide fractions by fractions. We've already worked with dividing fractions with whole numbers, and now we're going to take a closer look at when you have two fractions in your division problem. Make sure you have these notes loaded as well as the Virtual Manipulatives app, as we'll be using that a lot. Okay, so first we need to review reciprocals. And I'm sure you can see from all of the flip-flops that we're going to be reviewing that I like to call reciprocals, refliprocals. You got it. And remember, we call them reciprocal refliprocals because we flip what's on the top and what's on the bottom of each number. So in each pair of these flip-flops, we're going to go ahead and review finding reciprocals. So let's say you're given the fraction 1/4. The reciprocal of 1/4 is 4 over 1 or 4. Remember, 4 divided by 1 is 4. See, we've simply switched which number we put on the top and which number we put on the bottom. Let's try another one. Let's say this time you start with the whole number. Remember, that whole number 5 can be written as 5 over 1. And then to find the reciprocal, again, we simply just flip. And our reciprocal is 1/5. All right, let's try another one. Let's say you're given the fraction 2/3. The reciprocal would be 3/2. And you could simplify that to a mixed number if you wanted to. Another reciprocal. Let's say you were given the number 8, which remember is the same as 8 over 1. Flip that to become 1/8. Whoops, let me write that in a different color so you can see it better. There we go. Okay, got some cute heart flip-flops here. Let's say you were given a mixed number, 3 1/3. First, we need to change that to an improper fraction, and then we're going to flip it. So if we use MAD, 3 times 3 is 9. 3 times 3 is 9, plus 1 more is 10. Denominator stays the same as 3. And then 10/3 flips to become 3/10. Let's try another one. Say you're given the fraction 4/5. The reciprocal is 5/4. All right. Let's say you were given the number 9. Remember, the reciprocal is 1/9. So once you get comfortable with these, you can start doing more of them in your head. Let's say you were given the number 10. The reciprocal is 1/10. Let's say you were given the fraction 4/9. Oops, let me change that color again. The reciprocal would be 9/4. Okay, a couple more. Let's say you were given the the fraction 1/3. Reciprocal would be 3 over 1, which simplifies to 3. You were given the number 118. The reciprocal would be 1/118th. So even those big numbers scare you, they work the same way. Or if you were given the number, let's see, 2,104, the reciprocal would be 1/2104th. That's it. Okay, so now that we've reviewed reciprocals, we can move on to our work with dividing fractions by fractions. We're actually going to be learning two different methods here. One's going to be using a model using that Virtual Manipulative app, and the second method is going to be using an equation, very similar to our work when we divided whole numbers by fractions. So let's first review the steps for each method. When we're dividing fractions by fractions, for the first method using a model, which remember that means we're representing the fraction so we can see what we're doing, first step is going to be to model the first fraction. Which remember that first fraction is called that's right, the dividend. Okay? Once we've modeled that first fraction, the next thing we have to do is we have to see how many times the second fraction fits into the first. And that will make more sense once we start doing it. So how many times the second fraction, which remember is the divisor, fits into the first fraction. And however many times it fits is our quotient. It's as simple as that. Okay, now with method 2, using an equation, step 1 is we need to make sure any whole numbers are written over 1 and any mixed numbers are written as improper fractions. So let's write that down. So make sure any whole numbers are written as fractions and mixed numbers are written as improper fractions. Once we've ensured that that's true, the second step is to find the reciprocal of the second fraction and change our division problem to multiplication. So again, change to multiplication and find the reciprocal of the second fraction. And then our third and final step is to multiply, like you've already learned how to do. Okay, so now that we've learned the basic steps for each method, let's give our first problem a try. So our first example is 3/4 divided by 1/4. And we're going to start by using method 1, using a model. Remember, our first step is to model our first fraction, which in this case is 3/4. So I'm going to flip on over to the virtual manipulatives, and you should do the same. And we're going to go ahead, and I'm going to first just write down that our problem is 3/4 divided by 1/4 so we don't forget. And then I'm going to go ahead and model 3/4. And remember that each one of those fours represents 1/4 of a whole. We need 3 of them to represent 3/4. Okay, so now we need to see how many times our second fraction, 1/4, will fit into 3/4. Okay, so I'm going to pull out my 1/4 piece here. And I'm going to think, okay, it fits into 3/4 a total of 1, 2, 3 times. Again, it fits in 1, 2, 3 times exactly. So I can say that 3/4 divided by 1/4 equals 3. And that's it. So let's go ahead and take a picture. And we'll drop that into our notes. Got it. There's a reference. Okay, so remember method 2 is to use an equation. So I'm going to start by writing down my 3/4 divided by 1/4. I can see that I don't have any whole numbers. I don't have any mixed numbers. So I'm going to go ahead and I'm going to rewrite this problem as a multiplication problem. Our division sign becomes a multiplication. And that second fraction, we're going to find the reciprocal of that fraction. So 1/4, the reciprocal of that would be 4/1. Okay? Now, this is simply a multiplying fractions problem, and you're just going to use that same knowledge that you already have of how to multiply fractions. That's right, it's not going away. Okay, so hopefully you remember canceling for multiplying fractions. Remember, canceling means we look for factors on the top and the bottom that may have a factor in common. Do you see any? hopefully you see this 4 and 4 have a common factor of 4. So if I divide them both by 4, my 4's become 1's because 4 divided by 4 is 1. So I'm going to cross off my 4's and circle my new numbers of 1. I don't see any other numbers on the top and bottom with common factors, so I'm going to go ahead and multiply straight across. 3 times 1 is 3. 1 times 1 is 1. And we know that 3 over 1 can be simplified to 3. So we can see that using both methods, I get the same final quotient of 3. Okay, let's move on to our next example. Our next example is 8/12 divided by 1/6. Again, let's start this with modeling. I'm going to swipe over to the virtual manipulatives. And I'm going to start by modeling my first fraction, which in this case is 8/12. Okay, and before I forget, I'm going to go ahead and write down our original problem, which was 8/12 divided by 1/6. Okay, so now I need to see how many times my second fraction, 1/6, will fit into 8/12. So I'm going to pull out my 1/6 piece and see how many of these I can fit to 8/12. I'm just going to pull out a bunch because I'm not really sure how many we're going to need. Okay, so I'm going to go ahead and start matching those up. Aha. And so I can see that 1/6 fits in a total of 4 times. So my answer here is 4. So let's go ahead and take a picture and drop that into GoodNotes. Okay, now let's move on to our second method, which is using an equation. Again, I'm just going to start by writing the problem down, 8/12 divided by 1/6. I can see I don't have any whole numbers and I don't have any mixed numbers. So I'm going to go ahead and rewrite this as a multiplication problem. 8/12 stays the same. Our division problem becomes multiplication. I'm going to find the reciprocal of 1/6, which is 6 over 1. Okay? Once again, I'm going to look for things that I can cancel. And I see a number on the top and the bottom with a common factor of 6. Do you see them? That's right. 6 and 12 both have a common factor of 6. So if I divide them both by 6, 6 divided by 6 is 1. And 12 divided by 6 is 2. So I'm going to cross off my 6 and 12 and circle my new numbers, which are 1 and 2. Now you can also see that there's actually a second pair of factors here, which are 8 and my new 2. 8 and 2 are both divisible by 2. So if I divide them both by 2, my 8 becomes a 4, and my 2 becomes a 1. So I'm going to cross off my 8 and 2 and write 4 and 1. Now I can go ahead and multiply straight across. 4 times 1 is 4, and 1 times 1 is 1. So I get a quotient of 4 over 1, which I know simplifies to 4. And voila, we can see that using both methods, we get the same final answer. Hope you're starting to get the hang of this. Let's try another one. Okay, so our next pair of fractions is 1/2 divided by 1/4. Again, let's go to our virtual manipulatives and start with a model. I'm going to start by writing down my original problem, which was 1/2 divided by 1/4. And again, I'm going to start by modeling my first fraction, which is 1/2. Then I'm going to see how many times that second fraction, 1/4, will fit into 1/2. So now I'm going to pull out a bunch of 1/4 pieces and pull them underneath my 1/2. And there we go. We can see that it fits in a total of 2 times. So my answer is 2. Go ahead and take a picture. Drop it into GoodNotes. Okay, now we're going to try it using an equation. So I'm just going to start by rewriting my original problem, which was 1/2 divided by 1/4. All right, so we're going to start by rewriting this as a multiplication problem. 1/2 stays the same. My division sign becomes the multiplication, and I'm going to find the reciprocal of my second fraction. So 1/4 becomes 4/1. Before I multiply, I'm going to look for numbers on the top and bottom that have common factors. This is known as canceling. I'm going to go ahead and highlight the 2 and 4 because I know that they have a common factor of 2. If I go ahead and divide them both by 2, my new numbers are 2 and 1. I don't see any other common factors here, so I'm going to go ahead and multiply. 1 times 2 is 2, and 1 times 1 is 1. And we know that 2/1 simplifies to 2. And once again, we can see that voila, we get the same final quotient of 2. Okay, let's go ahead and try another one. 1/2 divided by 1/3. Okay, let's start with our virtual manipulatives. I'm going to start by writing down my problem, which is 1/2 divided by 1/3, and then go ahead and model my 1/2. And then we're going to go ahead and just pull out a bunch of 1/3 pieces. Not sure how many we'll need. So I'm going to go ahead and pull that up. Okay, I've got 1 in there. Okay. So I can see now that I fit one whole 1/3 piece in there. But then beyond that, a second 1/3 piece, only part of it fits. Well, what I need to see here is that how much of that 1/3 piece fits. 1/2 of this 1/3 piece, I'm sure you can see from the line here that this is now split in half. Okay, so a total of 1 and 1/2 times is how many times the 1/3 piece fits. So my answer here is actually 1 and 1/2. All right, go ahead and take a picture, and let's drop that into GoodNotes. Okay, now let's try this using an equation. So again, I'm going to write 1/2 divided by 1/3, and I'm going to rewrite this as a multiplication problem. 1/2 stays the same, division becomes the multiplication, and we're going to find the reciprocal of that second fraction. So 1/3 becomes 3/1. I'm going to look for common factors on the top and bottom. I don't see any, so I'm going to go ahead and multiply. 1 times 3 is 3, and 2 times 1 is 2. So I get a quotient of 3/2, which hopefully you can see that the improper fraction 3/2 simplifies to the mixed number 1 and 1/2. So once again, we see that we get the same final quotient no matter what method we use. Okay, let's try another one. Now we've got 1/4 divided by 3/8. Let's go ahead and pull up our virtual manipulatives. All right, and let's go ahead and write down our problem. So we've got 1/2 divided by 3/8. Start by modeling that 1/4, and then we're going to see how many times our 3/8 will fit in there. Now the important thing here is to remember that we're not just doing 1/8 now, we're doing 3/8. So this counts as 1 time going in, not 3 times. Okay? Okay, so let's start by pulling these pieces up. Okay? Okay. And we can see here that 2 of the 8ths fit in very nicely to our 1/4. But then this other 1/8 piece here of the 3/8 doesn't fit in very well. Well, if we think of the 3/8 as a whole, that means that 2 out of the total 3 pieces will fit in there. Or in other words, 2/3 of the 3/8 will actually fit in 1/4. So our quotient here is 2/3. Go ahead and take a picture, and let's drop that into GoodNotes. All right, now let's try the same thing using an equation. So again, I'm just going to start by writing down my original equation, which was 1/4 divided by 3/8, and I'm going to rewrite this as the multiplication problem. So we'll be writing 1/4 times, find that reciprocal, so we get 8/3. Before we multiply, look for numbers on the top and bottom with common factors. Do you see any? I see one, 8 and 4. Both of those numbers are divisible by 4. 4 divided by 4 is 1. And 8 divided by 4 is 2. So I'm going to cross off my old numbers, and I've got my new numbers here, 2 and 1. I don't see anything else I can cancel, so I'm going to go ahead and multiply straight across. 1 times 2 is 2, and 1 times 3 is 3. So we get a quotient of 2/3, which, if you remember, is the same that we got with our other method, so we know we did it correctly. Okay, let's try another one. Now we've got 2/3 divided by 1/6. Again, let's try it with the virtual manipulatives first. I'm going to start just by writing down the problem. So 2/3 divided by 1/6, okay? And then I'm just going to go ahead and start by modeling my 2/3. Okay? And then remember, once we've got 2/3 modeled, we're looking to see how many times 1/6 will fit into that 2/3. So I'm just going to pull out a bunch of 1/6 pieces, not sure how many we'll need, and start dragging them underneath my 2/3. Got 2 in there. Okay, so we can see that we can comfortably fit a total of 4 1/6 pieces. So that means the 2/3 divided by 1/6 is 4. Go ahead and take a picture, and we'll drop that into GoodNotes. Okay, second method, let's go ahead and use our equation. So we've got 2/3 divided by 1/6. Again, we're going to rewrite this as a multiplication problem. So we've got 2/3 times reciprocal of 1/6 is 6/1. You got it. Look for things you can cancel. I spy a 3 and a 6 that have a common factor of 3. I'm going to divide them both by 3. 3 divided by 3 is 1. And 6 divided by 3 is 2. So we're going to multiply my new numbers together. 2 times 2 is 4. And 1 times 1 is 1. And we know that 4/1 simplifies to 4. So once again, we get a final answer of 4. Okay, let's try another one. All right, now we've got 3/4 divided by 1/8. Let's go ahead and pull that up on here in virtual manipulatives. Okay. Oops, let me just double check something. Yep, okay. Just want to make sure I had the right problem, sorry. Okay, so I'm going to write down my 3/4 divided by 1/8. All right, and first steps first, model my 3/4. Okay. So we've got our 3/4 modeled. And again, we need to figure out how many times the 1/8 will fit in a 3/4. So I'm going to pull off a bunch of 1/8. Not sure how many we'll really need. And I'm just going to start placing them underneath my 3/4. Okay, and I can see that I can fit that 1/8 piece inside of 3/4 a total of 6 times. So we get a quotient of 6. Okay, go ahead and take a picture and drop that into GoodNotes. All right, and then let's try that also using an equation. So again, I'm just going to start by writing down 3/4 divided by 1/8. Okay, I'm going to rewrite that as a multiplication problem. So we've got 3/4 times 8/1. Look for things you can cancel. I see I've got a 4 and an 8 here. I'm going to go ahead and divide them both by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Nothing else I can cancel, so I multiply straight across. 3 times 2 is 6. 1 times 1 is 1. And we know that 6/1 will simplify to 6. So once again, we get the same quotient both times. All right, let's go ahead and try another one. 1/4 divided by 1/12. All right. Write that down. 1/4 divided by 1/12. Oops. So I'm just going to start by modeling 1/4, which I've got here. And I need to figure out how many times 1/12 will fit into 1/4. So let's just go ahead and pull out a bunch of 1/12 pieces. And I'm going to start placing them underneath the 1/4. All right, and I can see that the 1/12 pieces fit in a total of 3 times. So my quotient here is 3. Okay, go ahead and take a picture and drop that into GoodNotes. Okay. And now I'm going to just double check that using the equation. So I'm going to do 1/4 divided by 1/12. Okay. And I'm going to rewrite that as a multiplication problem. So 1/4 times 12/1. Look for things in the top and bottom I can cancel. I spy a 4 and a 12 that are both divisible by 4. So if I go ahead and divide them both by 4, 4 divided by 4 is 1. Cross off your 4. 12 divided by 4 is 3. Cross off your 12. And then we multiply straight across. 1 times 3 is 3. And 1 times 1 is 1. And then we know that 3/1 will simplify to 3. And once again, we see we get the same quotient both times. Okay, so our next one is 1/2 divided by 2/8. So let's go ahead and pull it up in our virtual manipulatives. So I'm just going to start by writing my problem down. 1/2 divided by 2/8. And I'm just going to start by modeling my first fraction, which is 1/2. Okay? And remember, we want to figure out how many times 2/8 will fit into 1/2. So I'm going to pull out my 1/8 pieces, but remember that 2 of those are going to represent each group. Okay? So if I pull up 2 1/8 pieces, this represents one group of 2/8. Okay? So I'm just going to underline that so we remember that. Okay? Then I'm going to pull up another group here. Okay? And so we can see that a total of 2 groups of 2/8 will fit inside 1/2. So my quotient here is 2. Go ahead and take a picture and drop it into GoodNotes. And let's just go ahead and double check that using an equation. So we've got 1/2 divided by 2/8. So I'm going to rewrite that as 1/2 times 8/2 and look for things I can cancel. I see right here within the same fraction I can divide 8 and 2 by 2. So I'm going to go ahead and do that. 8 divided by 2 is 4. And 2 divided by 2 is 1. Okay, I also see I've got a second set of items I can cancel here with this 4 and 2. Once again, I can divide them both by 2. So I'm going to go ahead and do that. Okay. So now my new numbers here, I've got 1 times 2 and 1 times 1, which gives me 2 over 1, which simplifies to 2. So once again, we get the same final answer. All right. Okay, now that is going to conclude our lesson on dividing fractions by fractions. Make sure you do the note check before moving on.